Hello students, I'm back. So students, let us start with the next module of the chapter rotational motion. In this module, we are going to discuss the concept of moment of inertia. Now students, in this module, we are going to derive three important formulas. The first formula is moment of inertia of a single particle. Second formula is moment of inertia for system of particles. And the third formula is moment of inertia of a rigid body. So very important module, students. So, are you ready? Can I start? Fine. Let us move on to the module. First, I'm going to discuss the formula for moment of inertia of a single particle. Students, for this, I'm going to consider a single particle. This particle is of mass m and this particle is rotating. Now for rotation, we require an axis. So this particle is rotating about an axis AB in the anti-clockwise direction, and this particle is at a perpendicular distance r from the axis. What distance? Perpendicular distance r from the axis. So r is your perpendicular distance from the axis. So what is the moment of inertia of the single particle? Moment of inertia of this single particle is given as I is equal to mr square, where m is the mass of this particle, r is the perpendicular distance of this particle from the axis of rotation. Is that clear? Now, what is the SI unit? Of course, SI unit will be mass is kilogram and distance is meter, so kilogram meter square. And what are the dimensions? Dimensions will be m raised to 1, l raised to 2 and t raised to 0. Is this clear, students? Moment of inertia of a single particle is mr square, and what is r? Yes, it is the perpendicular distance of the particle from the axis of rotation. Fine. Next, we are going to find out the moment of inertia of a system of particles. For this, I'm going to consider a system of two particles. First particle is of mass m1, second particle is of mass m2. Alright, these two particles are rotating. Now again, for rotation you require an axis. So these two particles are rotating about an axis AB in the anti-clockwise direction. Now the first particle is at a distance of r1, not just distance. It is at a perpendicular distance r1 from the axis of rotation, and the second particle is at a perpendicular distance of r2 from the axis of rotation. Now, I need to find out the moment of inertia of the system of particles. So what is the formula? The moment of inertia of this system of two particles is given as I is equal to m1r1 square plus m2r2 square. m1r1 square is the moment of inertia of the first particle, m2r2 square is moment of inertia of the second particle. So I system, which is the moment of inertia of the system of particles, is m1r1 square plus m2r2 square. Is that clear, students? Fine. Now you need to keep this in your mind. If I ask you, what is the moment of inertia of n particles? What you will do? Very simple. For two particles, it is m1r1 square plus m2r2 square. Then for n particles, it will be, yes, for n particles, we can write I is equal to summation of small I equal to 1 to n miri square. Alright, it's very simple formula, students. For two particles, you have it over there. For n particles, it will be just the summation. Is that clear? Now this formula is very important. Alright, any doubts till now? No. Fine, let us move on to the next one. Here I have to find out the moment of inertia of rigid bodies. For this, I'm going to consider a rigid body. This rigid body is rotating about an axis AOB. Alright, and this rigid body is rotating in the anti-clockwise direction. And this rigid body is rotating with a constant angular velocity omega. Now this axis AOB is perpendicular to the plane of rotation of the rigid body. Now students, this rigid body is made up of continuous distribution of mass. See, here it is not discrete particles. This rigid body is made up of continuous distribution of mass. Continuous distribution of mass means this rigid body is made up of many small mass elements. Alright, continuous distribution of mass. So what I'm going to do here is, I'm going to consider one small mass element dm, and this mass element is at a perpendicular distance of r from the axis of rotation. R is the perpendicular distance, alright, from the axis of rotation. Is that clear? Of dm from the axis of rotation. Now, let me find out the moment of inertia of this mass element. What is moment of inertia of this mass element? See, mass is small. So then the moment of inertia will be di. Di is equal to dm into r square. Now, we all know this rigid body is made up of many such mass elements, continuous distribution of mass. So then the moment of inertia of the rigid body is given as I is equal to integration of di. And what is integration of di? I is nothing but integration of, we know di. Di is dm r square. So I is equal to integration of dm r square. Remember students, this is a rigid body which is made up of continuous distribution of mass. Is that clear? So we have seen three formulas. First one is moment of inertia of a single particle. Second one is moment of inertia of system of particles. The third one is moment of inertia of the rigid body. All these three formulas, especially the third one, we'll be using this in solving numericals as well as in your entrance module. Is that clear? One thing you have to keep in your mind. R is the perpendicular distance of the mass of the particle from the axis of rotation. Remember this. Alright, fine students. So we come to the end of this module. I'll catch you up in the next module. Until then, keep working students. You can do it. Rise and shine.